Hey guys, welcome back. I'm hyped to be doing some genetics questions because this section is super fun. If you really like problem solving, you will like this section. So we have a normal woman, she wants to marry a normal man, but both of them have albino parents, and we know that albinism is an autosomal recessive disease. Autosomal just means it is not on a sex chromosome, which will mean more once we start dealing with sex chromosomes. And it's recessive, so that lets us know that little a, those will appear albino. So when we're thinking about little a and albino, which one is the genotype and which one is the phenotype? Hopefully by now we're on the same page that the genes are the genotype, and these are what cause the phenotype. Right, so phenotype is what you can see, right? You can look and be like, oh, okay, they're albino, but you can't really look at someone and be like, I know you have two little a alleles. Let's go ahead. It's kind of helpful to write down all the genotypes and phenotypes when you first start doing genetics questions, just so you can look back at your work. On the other hand, a big A blank, that would be normally pigmented. Normally pigmented. And just so we're on the same page, you're going to see A blank. This just means it could either be big A, or big A, little a. Both of these genotypes would have a normally pigmented phenotype, so we don't need to distinguish between big A, or big A, little a. We just write big A blank because both of these would look normal. Cool. So I think this question, since we have a lot of information in this first sentence, it's going to be a little bit more clear if we draw it out like a family tree. So let's go ahead and do that. So we have this normal woman. Remember, women are circles in this. The father was albino, so I'm going to color him in, right? If someone's colored in, means that they have the trait. It doesn't tell us anything about her mom, but if the mom would have been albino, the question would have told us. Cool. And so she wants to marry this normal man whose mother was albino, so maybe, you know, that's how they bonded and why they fell in love. So his mother is albino, and we're just going to assume his father's normal. Want to know what is the probability that their child is albino? So before we figure out more about this child, we need to figure out more about the child's mom and the child's dad. Now that we have a family tree on here, let's go ahead and write down all the genotypes we know for sure. So for example, everyone who's albino, we know is little a, little a, little a, little a. Cool. Everyone who's normal, we know that they're big A blank. I'm just gonna actually save that. Cool. So our goal is to know more about both of these parents. Let's think about their parents and what they can tell us about them. Right, so for example, this dad has two little a's. What allele did he give his daughter? He could only give his daughter a little a allele. He has nothing else to give. So this woman for sure has a little a. What allele did her other parent give her? Well, think about what we know about this woman. This woman's normal. She's not albino, so she does not have two little a's. That would be impossible, or else she'd be albino. That means her other allele has to be big A. So we know for a fact, we just figured out that this mom is a carrier. Notice that we never figured out this parent. We never figured out if they were big A, or big A, little a. We never figured that out. And it doesn't matter for this question. We only care about this mom, and we know for certain that she's big A, little a. Let's go ahead and move here. Same deal on this side of the family, right? This person had to give their child a little a, and they're normal, so they must have a big A to keep them normal. So this person is also a carrier. Cool, so we know about both of these parents, and to figure out stuff about the child, you have to do a Punnett square. So this mom has a big A and a little a. In one gamete, she could have given a big A, or in another gamete, she could have given a little a. Equal chance. On the other hand, the dad could have given a big A or a little a. Equal chance. This is what we do for a Punnett square, right? These are the possible gametes the mom could have given. These are the possible gametes the dad could have given. And then we just fill it in. 2 big A's, big A, little a, big A, little a, little a, little a. Cool. Since the question's asking what's the probability the child is albino, we're looking for which genotype here would lead to an albino phenotype, and that would be this. And this is 1 out of our 4 options from our Punnett square.